Something strange is happening in Egypt's desert. Giant, mysterious green circles are popping up everywhere, hundreds of them. And then you've got dozens of canals and roads connecting into something that looks like a river. But it's not exactly that. This is the ambitious New Delta project, and it has one controversial goal: to flood the desert. It's easy to see why. More than 90% of Egypt is desert, miles and miles of sand dunes and dry land under scorching heat. Almost nothing can grow there. So today there are basically only two areas where Egypt can grow large amounts of food: the Nile Valley and the Nile Delta. Together they cover only about 5% of the country's land, but their crops feed about 99% of Egyptians, and that's becoming a real problem because Egypt's population keeps growing. By 2050, estimates say their population will grow by about 40 million people, reaching nearly 160 million. The Nile Valley and the Nile Delta just won't be enough to handle that kind of demand. See the problem here, right? The population is growing, people need more food. But most of the country is desert, and there's not much room for new farms. So what can they do? The easy solution is the same one you use when your fridge is empty. You order in. Egypt does that too. They buy huge amounts of food from other countries. But importing food is expensive and time-consuming. So they need to create more space for farms. And they need it fast. That's where the New Delta project comes in. This is a massive agricultural plan meant to turn parts of the desert into green fields. The idea is to move water and farming west of the Nile. And if it works, it could expand Egypt's farmland by about 15%. Sounds great on paper, right? But in reality, this plan comes with a lot of controversy. Their idea is to create an artificial river right in the middle of the desert, about 70 miles long. To make it work, they're building tons of roads and canals to support it. And those strange green circles I mentioned earlier are irrigation systems. They pull water up from wells or pipelines, then slowly spin around and spray water in a big circle over the crops. Okay, so we've got this huge artificial river being built in the middle of the desert, but where is all that water coming from? Well, it comes from three main sources. The first, and by far the biggest, is treated wastewater. They take used water, the kind that goes down sinks and toilets in our homes, for example, and clean it up so it can be used safely again. To do that, they had to build a modern treatment plant in El Hammam, a town in Egypt's northern coast west of Alexandria. Its construction was completed in 2023, and it's absolutely massive. It's so big that it now holds the world record as the largest wastewater treatment plant in the world. It cleans an enormous amount of water every day, enough to fill about 3,000 Olympic-sized swimming pools, and most of that water goes straight to farming. The second source of water comes from the Nile. Basically, they're taking water from Egypt's most famous river, sending it through massive canals and pushing it deep into the desert, into this new, man-made river. Finally, the third source is deep fossil groundwater. In other words, it's water from way under the desert. Down there is something called the Nubian Sandstone Aquifer, basically a huge underground reserve of water that's been trapped for thousands of years. And this is where the controversy starts. It's true that there's a lot of water under the western desert, but it's limited. Because this is fossil water, it's so old that it doesn't really get replaced. Once you pump it out, it won't refill anytime soon, not in our lifetime, and probably not even for many generations. On top of that, the deeper you drill, the saltier the water can get, and we don't want that. You see, most crops don't like salt. If the water is too salty, plants grow slower, give smaller harvests, or dry out. And when you keep watering with salty water, salt builds up in the soil. The water evaporates, but the salt stays. Over time, the land can turn hard, dry, and basically useless for farming. So pumping groundwater might help in the short term, but it raises a big question. Is this really doable in the long run? And there are other concerns too. The project was sold as a big win. Grow more food, create more jobs, and help Egyptians. It also boosts the economy because they're growing expensive fruits and vegetables that get sold abroad to places like Canada, Australia, and Japan. But that's also the problem. Many people complain that the project is mostly about growing crops to sell abroad. And sure, exports bring money into the country, in the big picture, but that doesn't necessarily mean food gets cheaper at home, or that poorer families can afford more. Because even though it has boosted exports, it hasn't done much to prevent massive food price inflation inside the country. So, Egypt's food security problem still isn't fully solved. Many Egyptians are still dealing with high prices and tight budgets. Another controversial thing is that no one knows how much this project actually costs. The press sometimes mentions $5.2 billion, but some experts put the total closer to $9.7 billion. Just the wastewater treatment part alone is said to cost more than $500 million, but it's very hard to know for sure. Journalists and researchers say there isn't much transparency, and the project's finances are tough to track. Experts also warn that farming in the desert is crazy expensive. Unlike the rich soil in the Nile Valley, the western desert is mostly dry sand with very few nutrients. So if you want to grow anything out there, you need tons of irrigation just to make the land workable. And powering all those irrigation systems takes a ton of energy, making farming in the desert even more expensive, even if you already have a giant artificial river to help you out. Still, some people argue the risks and the costs are worth it, and that things are starting to change. Take wheat, for example. For years, Egypt has been the #1 wheat importer in the world, and that's not exactly a title you want to win, because it costs the country billions of dollars every year. So then the new Delta project comes along, and wheat becomes one of their main targets. Egyptian authorities say it helped them cut wheat imports by 17% in 2025. That saved them around $250 million. This was such a big achievement that the world now has a new #1 wheat importer, China. And it's not just wheat. Oranges, potatoes, grapes. Agriculture is booming over there. According to estimates, food exports jumped from 5 million tons in 2020 to over 8 million tons in 2024. That's why we can say the new Delta project is already changing Egypt's agriculture. And from satellite images, you can see it's changing what the country looks like too, turning dry desert into bright green patches. It's real, and the transformation is pretty dramatic. So there's no doubt this project is both an impressive engineering achievement and a huge experiment. But researchers say it's still too early to know if it will actually solve Egypt's food problem. In the end, it all depends on water, energy costs, and who gets to make the big decisions. If the Nile, treated wastewater, and fossil groundwater can be managed in a sustainable way, the project could seriously boost farming. And if not, it could drain precious water, make the gap between rich and poor even bigger, and leave behind an expensive footprint on the desert.
When rivers dry up, when plants can no longer survive on hot, lifeless plains, when ecological disaster feels inevitable, they arrive to save the world. They being wolves, rabbits, and beavers. Now you're about to hear stories about how animals saved ecosystems across the planet. And, well, let's start with rabbits. And here's a little disclaimer. There are no reliable sources on the internet confirming that this first story is true. Nevertheless, it seems quite truthful. Believe it or not, it's up to you. Welcome to the Dalit Banner Desert in China. Yup, it says desert, so why does it look like a green oasis? Just a few decades ago, this place was a vast, lifeless expanse of sand. Plants couldn't survive here, trees couldn't grow, animals couldn't live. A massive piece of land produced nothing and supported no life. It was sad that such a huge territory brought no benefit at all. So specialists there began searching for ways to bring life to this place. They considered planting trees, artificial irrigation, large-scale greening projects, and other traditional solutions. But all of these ideas seemed inefficient, expensive, or unlikely to succeed. Then, in 1988, one Chinese scientist proposed a radical solution. he suggested releasing rabbits into the desert. The idea was met with curiosity and interest. Soon after, a colony of Rex rabbits, a French breed, was brought to Tidal. These cute little animals adapted surprisingly well to the dry and hot environment and began to settle in. Under these harsh conditions, each rabbit started digging into the ground in search of roots and dry grass. On a massive scale, this digging aerated the soil. Aeration means enriching the soil with oxygen, which is essential for plant growth. And when the rabbits went to the toilet, well, let's put it politely, they enriched the soil with nutrients and undigested seeds. All of this helped revive the desert and slowly turn it into a green valley. But how was this possible, considering that the number of rabbits was limited at first and the desert itself was enormous? The answer is simple. Rabbits reproduce extremely fast. Each rabbit can produce around 40 offspring per year. Over time, the population exceeded 1 million animals. On top of that, there were no dangerous predators in the area to threaten them. They multiplied, worked the soil, and continued doing exactly what nature designed them to do. Scientists were amazed. The results exceeded all expectations. Plant survival rates reached 96%. Farmers around the world learned about the impact rabbits had on the environment. Rabbit farming quickly became a profitable business. Everyone wanted these animals. Farmers began earning tens of thousands of dollars. The economic level of the region rose, and with it, the quality of life for locals. The desert land became fertile enough to grow potatoes. Farmers began producing more than 1,000 tons of potatoes per year. This was good not only for earning money, but also for creating new jobs. Simple rabbits revived the land, turned a desert green, and brought economic growth to the entire region. Now, here's the grain of salt you need to take with this story. There are no reliable sources we've been able to find so far that this 1988 rabbit mission is true. But the following two stories are actual confirmed cases. Our next helpful animal is the beaver. Now we move from China to the United States and to the state of Utah. Rising temperatures cause rivers in this region to dry up. The ecosystem found itself in a dangerous situation because rivers are a vital resource here. Animal life, agriculture, tourism, and access to drinking water all depend on them. Severe drought dried up rivers. Fish populations suffered, and animals that depended on those fish began to struggle. The risk of forest fires increased because of a lack of moisture. One problem followed another, and no one knew how to solve them. Then, in 2019, a group of researchers from Utah State University proposed an unusual solution. They decided to relocate beavers to the Price River. But how could animals that chew trees possibly fix such a serious problem? Well, beavers build dams. Along rivers, these dams create small ponds and wetlands. During droughts, water stored in one place lasts longer, while water stretched along long riverbeds quickly evaporates under the burning sun. Fish and other animals use these ponds as shelters, surviving difficult periods there. After that, when the rainy season returns, rivers recover. Beaver dams help fish populations survive, reduce the risk of forest fires, and improve access to nutrients. Forest animals that feed on fish don't starve, and the whole ecosystem endures droughts more successfully. Now, there's one downside to this method. Not all beavers adapt to a new environment. In the case of the Price River, some of the relocated animals didn't survive. Some faced predators. Some couldn't stand the new weather conditions, but the majority did their job well. Today, the water level in the river is higher. Fish are abundant. Residents are happy that the region attracts tourists. People come to relax on beaches, swim, kayak, and go fishing. All of this prosperity exists thanks to beavers. Now, let's move to the famous Yellowstone National Park, one of the largest nature reserves in the world. In the last century, a single species nearly destroyed its entire ecosystem. When we hear stories like this, we usually imagine swarms of locusts eating every plant in sight or mosquitoes spreading diseases. But to disrupt nature's balance, it doesn't always take a small, fast-breeding creature. Sometimes the cause can be a large animal, like the elk. You see, at one point the elk population in Yellowstone grew rapidly. They began feeding on huge amounts of willows, aspens, poplars, and other trees. Their appetite seemed endless, and as their numbers kept increasing, they were slowly stripping the forest bare. By eating leaves, damaging trunks, and breaking branches, the elk destroyed the natural shelters that birds depended on. Without these trees, many bird species could no longer survive the winter. As bird populations declined, predators that relied on them for food began to struggle as well. Birds also play an important role in controlling insects, so bugs probably started to multiply rapidly. But this still wasn't the most serious problem. The elk changed the region's water temperature. As trees disappeared, beavers lose food for winter, which is willows. So the beaver didn't build enough dams. These dams, along with trees, provided shade that cooled the water. Without them, Yellowstone's rivers began to warm. Cold-blooded fish suffered as water temperatures rose, and without these fish, many animals began to starve. A long and complex ecological chain had been broken because of elks. Something had to be done. But what? Destroying the animals wasn't a real solution. It would only offer temporary relief, and besides, the elk weren't to blame for following their instincts. So scientists turned to a very different answer: wolves. Yep, that's right. In early 1995, people brought 8 wolves to Yellowstone. By 1996, their number had grown to 31. In 2002, 30 wolf pairs were distributed across different parts of the park, and within just 10 years, Yellowstone began to change. The presence of wolves forced elks to move constantly and stay alert. Their population decreased, and their behavior changed. They could no longer linger in one place long enough to destroy entire groves of trees. Vegetation slowly recovered. Willows and aspens grew stronger. Birds returned and rebuilt their nests. Beavers once again had enough wood to build dams. Rivers cooled under their shades. Step by step, the ecosystem healed. Wolves had saved the forest. But wait a minute. Why weren't there wolves already in Yellowstone? Well, the answer is humans. In the 19th century, when Yellowstone was declared a national park, wolves often attacked livestock, and they had a reason. Settlers built ranches nearby and brought large numbers of non-native sheep and cattle into the region. At the same time, they hunted the park's natural herbivores, leaving wolves with little food. Desperate to survive, wolves began attacking ranch animals. At the time, people saw wolves as pests. The solution seemed obvious. For decades, hunters wiped out entire wolf packs. By the mid-1920s, more than 130 wolves were gone, and in 1926, the last pack was eliminated. By the 1970s, there were no signs of wolves left in Yellowstone. And after that, the elk problem appeared. That's why it's so important to treat animals with respect. They aren't just creatures that eat, sleep, and hunt alongside us. It turns out that they are essential parts of the natural web of life. And when even one piece of this system is removed, the entire thing can begin to collapse. Something to think about. You know, we've all begged for just one extra hour in the day. Actually, 2 hours would be better. Well, scientists have good news and bad news. The good news is that our planet is heading toward a future where a day could last 25 hours. The bad news is that eventually, the same physics that makes the day longer will also get rid of our planet's rotation, literally freezing Earth in time. Meaning endless days and nights and oceans fleeing to the poles, all while the atmosphere turns into a relentless planet-wide storm. Uh-oh. Now, back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that debris smashed together, it started to swirl, like water rushing down a drain, but on a cosmic scale. That spin caused a momentum. Since space is a vacuum, there was no air to slow us down. Earth just kept spinning, and that spin became a day. One full rotation takes about 24 hours, and that's the rhythm we've known since we started recording time. But the thing is, we adopted 24 hours as a close estimate. In truth, a day is never exactly 24 hours long. Now, basically, Earth keeps spinning, but it's constantly losing tiny bits of speed. That's mostly because mass keeps moving around. Think of it like a figure skater. If they pull their arms in, they speed up. If they put them out, they slow down. Earth does the same thing, except without arms. When the 2011 earthquake hit Japan, it shifted the ocean floor so violently that it pulled Earth's mass inward, instantly shorting our day by 1.8 microseconds. Conversely, as glaciers melt and water rushes from the poles to the equator, Earth's arms are spreading out, causing us to drag. We're not just sitting on a big rock. It's like we're on a wobbly spinning top that moves every time something heavy happens on it. Most days end up being a few milliseconds longer than 24 hours. We can't feel this, but atomic clocks can measure it. Over long periods of time, those milliseconds add up. And as they do, the length of a day slowly increases. That's how a 24-hour day starts drifting toward 25. To check this, scientists pulled together nearly 3,000 years of sky records. Thousands of years ago, people carefully recorded eclipses. It was a scary event. Kings, priests, and astronomers wrote the exact time and location when the sun vanished. Those records survived on clay tablets, scrolls, and manuscripts. For the sky to go dark, the sun, earth, and moon must line up perfectly. If the timing is off by even a second, the shadow falls on the wrong part of the world. Today, astronomers know the moon's movements with incredible precision. They actually bounce lasers off mirrors left on the lunar surface to measure its orbit. That's why, in theory, we should be able to rewind the past like in a YouTube video and see every ancient eclipse exactly where history records it. But when scientists tried that, the moon showed up too early, or too late. The shadow wasn't where the record said it should be. The puzzle only solves itself when you realize one thing: Earth used to be a little faster. When researchers adjust Earth's rotation to be slightly quicker, everything snaps into place. In other words, Earth was spinning a little faster in the past, and these eclipse records show it. On average, this translates to a day increasing by about 1 to 2 milliseconds every 100 years. That's 1,000th of a second. You'll never notice it. But over time, those tiny bits stack up. About a second every 10,000 years. That means we are roughly only 200 million years away from having that one additional hour of sleep. So the good news turns out to be only meaningful for future Earthlings. But why is this actually happening? Well, the answer is the moon. Its gravity grabs Earth's oceans and stretches them into huge tidal bulges. But because Earth spins much faster than the moon moves around us, those bulges don't sit neatly under the moon. They get dragged slightly ahead as the planet rotates. That means the oceans are constantly being dragged across the planet, rubbing against the seafloor and the continents. That rubbing creates friction, and friction is a thief. Where there's friction, there's heat. So the moon slowly turns Earth's spin into heat that spreads through the oceans and into space. And once that energy is gone, it's gone for good. Since there's no visible cosmic creature to push Earth back up to speed, day after day, the moon acts like a slow, steady brake, stretching our days little by little and drifting farther away as it does. Yes, as much as we used to fear that the moon would collide with Earth one day, it's actually going in the opposite direction. All that transfer of energy that's happening between Earth and the moon is slowly pushing our satellite further away, approximately 1.5 inches per year. We know this because during the Apollo missions, astronauts left mirrors on the moon's surface, and today scientists fire lasers at those mirrors and time how long it takes the light to come back. However, even though we are slowly pushing the moon away, don't panic. It's not packing its bags just yet. At the current rate, it would take tens of billions of years for the moon to retreat significantly. but it will stick around long enough to witness and maybe even cause the end of all ends, so to speak. The same braking force that is slowing us down now could eventually push Earth into a state called tidal locking. This has actually already happened to the Moon. You know how we never see the dark side of the Moon from Earth? Well, that's because Earth's gravity grabbed the Moon eons ago and forced its rotation to stop relative to us. Well, if you give it enough time, the universe could return the favor. If Earth slows down enough to match its orbit around the Sun, the cycle of day and night will disappear. We could turn into what astronomers call an eyeball planet. Because the Sun would just hang motionless in the sky, the side facing it would turn into a blistering scorched desert. That's the pupil of the eye. The side facing away would freeze into a massive white shell of ice, the white of the eye. The only spot where life could hang on in this area is called the iris, a narrow strip caught between the crazy hot day and the frozen night. But even that wouldn't be a dream come true. You'd have super hot air on one side smashing into freezing air on the other. So this zone would be hit by insane hurricane-level winds whipping across the surface. Also, without Earth's spin shaping the oceans, water would slowly migrate away from the hot regions and collect in colder zones, reshaping coastlines and continents entirely. The planet wouldn't just have longer days. It wouldn't even look like Earth anymore. But here is the bright side. We will actually never see this happen, and neither will our descendants, at least not while watching from nearby. The math says it would take about 50 billion years for Earth to stop spinning and turn into that frozen eyeball fully. But our Sun doesn't have that kind of time. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant, swallowing the inner planets and likely vaporizing Earth entirely. Bye-bye! So, while Earth is slowing down, it will never actually get to zero. We won't end as a frozen, motionless rock. We'll end as we started, space dust. By the time Earth ever stops spinning, humans certainly won't be watching from the solar system. We might be scattered across the galaxy, living in space, or not even human anymore. Some of us could live inside massive structures built around stars, capturing their energy instead of orbiting them. Others might drift near black holes, using their gravity and energy in ways we barely understand today. Entire civilizations could exist as uploaded minds, connected through a galaxy-wide network, living in simulations instead of physical worlds. Well, wherever we are, Earth would just be an old planet concluding its story.